Good morning all. Now I am going to explain about Viva questions on basic electrical and electronics engineering. Okay. Here first question is define current. See here, current is nothing but the flow of electrons or flow of charge for a given time period is known as current. Okay. The units for current will be either amperes. Okay. But already we know that current I is equals to Q by T or dq by dt, right? From that equation, units for current will be coulombs per second. Okay, that is the first question. Define current. Next, define voltage. Okay, now see here, let us consider a circuit. Okay, let us consider a resistor and apply a battery voltage of V volts. This is a resistor, right? Because of this battery voltage, current I is flowing. Current is nothing but flow of electrons or flow of charge for a given time period, right? Now see here, because of this current, that means current is produced because of this voltage, right? That means because of this voltage only there is some work done, right? That is nothing but voltage is nothing but work done to move unit positive charge is nothing but voltage. Okay, then voltage formula will be voltage V is equals to work done divided by charge. Okay, units for voltage will be volts or from this formula voltage V is equals to work done by charge, right? Already we know that units for work done will be joules, right? Units for charge will be coulombs, right? Then units for voltage will be joules per coulomb. Okay, next question is DC voltage. Okay, now see here, there are two types of voltages, DC voltage and AC voltage. Okay, in case of DC voltage, now see here, this is the magnitude, right? The magnitude of DC voltage is constant with respect to time. See here, on x-axis time, y-axis voltage, right? Here time is varying from 0 to infinite, right? But the magnitude of voltage remains constant. That is nothing but DC supply, DC voltage. Okay, that means DC supply is having constant magnitude. Okay, this is the representation of DC voltage. Okay, DC supply is having polarities. Okay, current always flows from higher potential to lower potential. Remember this point. Okay, that means here in case of DC system doesn't have any frequency. In case of DC supply, frequency is 0 Hz. Okay, next AC voltage. Okay, now see here, this is the nature of AC supply. Okay, that is the magnitude of voltage and current alternatively changes. That means voltage is changes from 0 to 230 for single phase system, 230 to 0, 0 to minus 230, again minus 230 to 0. That means the magnitude of voltage and current is alternatively changes. Okay, in case of AC system, frequency plays a major role. Okay, here frequency, the relation between frequency and time period is frequency F is equals to 1 by T. Okay, whereas AC system doesn't have any polarities. Okay, this is the representation of AC system. Okay, next, that is about AC voltage. Next question, define Ohm's law. Okay, the statement of Ohm's law is at a constant temperature, the current flowing through the conductor is directly proportional to the voltage or potential difference. Now see this circuit. See here, because of this voltage only current I is flowing, right? The current flowing through the conductor is directly proportional to the voltage. That is the statement of Ohm's law. That is I is directly proportional to phi. From this equation, V is directly proportional to I. If I remove the proportionality constant, V is equals to I into R. This will give the relation between voltage, current and resistance. Okay, that is about Ohm's law. Okay, next coming to limitations of Ohm's law. Sometimes maybe there may be a chance to ask limitations. That means Ohm's law cannot be applicable when temperature changes. Ohm's law cannot be applicable to non-linear devices. Ohm's law cannot be applicable to semiconductors and vacuum tubes. Okay, that is about Ohm's law. Next, already we know that R is a proportionality constant from Ohm's law. Okay, then from that equation, first resistor R. Resistor is nothing but which opposes flow of electric current. Okay, it is denoted by capital R. For example, again let us consider same circuit. Let us say assume resistance value is 10 ohms. Assume voltage will be 10 volts. Then what is the current? I is equals to 10 by 10, 1 ampere. Next case, this resistance value is increases to 100. Then current I is equals to 10 by 100. Current will be 0.1 amperes. Next case, resistance value is reduces to 1 ohm only. That is 10 by 1, 10 amperes. Okay, from these three results, when resistance value is low, magnitude of current is high. When resistance value is high, magnitude of current is low. That means a resistor is nothing but which opposes flow of electric current, okay, which is denoted by capital R. Okay, the units for resistance will be ohms. Okay, that is about resistor. Okay, next, conductance G. Okay, conductance G, which is reciprocal to the resistor. What is meant by resistor? Resistor which opposes flow of electric current, right? Whereas conductance G, which allows electric current through them. Those are nothing but conductance. Okay, conductance G is equals to 1 by R. Okay, that means units will be 1 by ohm. 1 by ohm is nothing but reverse of ohm. Ohm, right? MHO, reverse. OHM, ohm, MHO. Reverse of ohm is nothing but mhos. Units for conductance will be mhos. This is the symbol of mho, reverse of ohm symbol. Okay, that is nothing but conductance G. Next, inductor L. Okay, see here inductor is a energy storage element. It stores the energy in the form of electromagnetic field or magnetic field. See here it is the symbol of inductor having a inductance L. Okay, then the energy stored in inductor will be half Li square. Okay, the units for inductance will be Henry. Okay, that is about inductor. Next, the special property of inductor is inductor doesn't allow sudden change in current. Remember this point. Okay, that is about inductor. Okay, next, capacitor. Capacitor is nothing but capacitor is also a energy storage element which stores the energy in the form of electrostatic field. Okay, units for capacitor will be farads or F. Okay, majorly the capacitance range will be in the range of microfarad, nanofarads and picofarads. Similarly, in case of inductor, inductance range will be available in millihenry and microhenry only. Next, the energy stored in capacitor will be of CV square. Okay, the special property of capacitor is capacitor doesn't allow sudden change in voltage. Okay, next, very important, series connection and parallel connection. Okay, now see here, first series connection. Let us consider three resistors, resistor R1, R2, R3. Series is nothing but finishing end of one element is connected to starting end of another element. Finishing end of one element is connected to starting end of another element. Then those elements are said to be in series. Either it is a resistor or it is an inductor or it is a capacitor. Now see here, in series connection, the equivalent resistance will be R1 plus R2 plus so on Rn. Okay, now see here, in series connection current is same, right? There is no another path for current, right? In case of resistor or in case of inductor or in case of capacitor. Okay, that means in series connection current is same. Next point will be voltage is different for different value of resistor. Right, the resistor, if it is an inductor then it is inductor. Voltage is different for different value of, if it is a capacitor. Here it is a printing mistake. Here it is a inductor and here also here it is a capacitor. See here, in case of resistors, the equivalent resistance will be R1 plus R2 plus so on Rn. In case of inductors, equivalent inductance will be L1 plus L2 plus so on Ln. But in case of capacitance will be different. You can remember this formula, that is 1 by C equivalent is equals to 1 by C1 plus 1 by C2 plus so on plus 1 by Cn. Okay, that is about series connection. Next, parallel connection. We're coming to parallel connection. See here, starting end of the elements are connected to common point, right? Three resistors starting end is connected to common point, finishing end also connected to common point. Then those elements are said to be in parallel. Either it is a resistor or it is a inductor or it is a capacitor. Okay, in parallel connection voltage is same. That means voltage across resistor R1 is V only, voltage across resistor R2 is V only, voltage across resistor R3 is also V only. Then the equivalent resistance formula will be 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus so on 1 by Rn. Similarly, in case of inductances also, 1 by L equivalent is equals to 1 by L1 plus 1 by L2 plus so on 1 by Ln. Okay, but whereas in case of capacitances, in parallel the capacitances will be added, that is C equivalent is equals to C1 plus C2 plus C3 plus so on Cn is the answer. Okay, that means in parallel here voltage is same, either it is a resistor or it is a inductor or it is a capacitor when they are connected in parallel. Okay, but whereas current is different for different values of resistor. Okay, that is about parallel connection. In series connection, remember one formula, in series connection resistances and inductances will be added. In series connection current is same. Next, in parallel connection voltage is same, right? R equivalent formula will be 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus so on plus 1 by Rn. Okay, that is about series and parallel connection. Next, define active elements. Okay, the elements which gives energy to the circuit is nothing but active element. See here, let us consider again same circuit, starting circuit diagram. 5 volts, 5 ohm. Okay, without this source there is no energy. Energy is nothing but power into time. Power is nothing but product of voltage into current. Okay, current is flowing because of the presence of voltage only, right? Without voltage no power or no energy. That means which is giving the energy to the circuit here, voltage source or current source. That means the element which give energy to the circuit is known as active element. Okay, from this circuit here voltage source is the active element. Suppose if I replace voltage source with current source, that is also a active element. That is nothing but voltage source and current source are the example for the active elements. Okay, that means the elements which give energy to the circuit is nothing but active element. Okay, next, define passive elements. Okay, the element which receives or consumes the energy, those elements are known as passive elements. Example, resistor, inductor, capacitor. Okay, resistor will consumes energy. Consume means only heating element it is, whereas inductor and capacitor are the energy storage elements. In electrical there are only two energy storage elements are there, that is inductor and capacitor. Okay, that is about some basic Viva questions. Remaining we will continue in next class. Okay, thank you all.